Welcome. Let's take a look at what I'm referring to as kind of physics calculus. This same questions as are asked on our JTB, just a little bit different approach. So we've got a particle or a squirrel moving along a horizontal wire in position. Its position is given in the S function down here, and we're only interested when time is greater than or equal to 0, so the squirrel can only go to the right or the left. For each problem, find the velocity function. Well, velocity is the change of position on change of time. That's ds dt. We just want s prime of t. And s prime of t is the velocity function. So this would be calculus speak. Here's physics, what we're transitioning to right now. So velocity is 2t minus 14. For each problem, find the velocity function, the acceleration function. Acceleration function is the change of velocity over change of time. It's really the second derivative of position. But we're transferring from calculus speak into physics speak here. We would refer to the second derivative as acceleration. So that is the derivative of this, which is 2. The times t when the particle changes direction. Okay, so we're supposed to find the velocity function, got it. The acceleration function, got it. The time when the particle or the squirrel changes directions. Well, the squirrel changing directions doesn't have anything to do with acceleration. It has to do with velocity. If the velocity goes from positive to negative or vice versa, the squirrel's turning from right to left or left to right, as the case may be. So I'm interested when 2t minus 14 equals 0, and that happens, of course, when t is 7. Let's look at a sign chart. Only interested in 0 on. So we put in 7, we get 0. I put in something smaller than 7 like 1. 2 minus 14, we get a negative. Squirrel is moving to the left to begin with. And then put in something bigger like 10, and we get 20 minus 14, 6 positives. I'm going to draw a quick sketch of this graph. It starts up 45, it's going down very steeply, and eventually turns up. Now, does it get below the x-axis? It might. Not sure. But I do know my squirrel started by reducing its position. Reducing its position on the wire would mean it's moving to the left. So reduced its height, or its position, and then increased its position. So this just has a whole lot to do with increasing, decreasing. Same thing as our JTBs. So we change direction at t equals 7. The squirrel is moving to the right from 7 to infinity, to the left from 0 to 7. And we'll be moving left if we went negative, but we're only supposed to look when t is bigger than or equal to 0. So let's see, when the particle changes directions, the interval of time when the particle is moving left and moving right. The time t when acceleration is 0. Well, acceleration is 0 when 2 equals 0. Never. And the intervals of time when the particle is accelerating. That's the same, that's the physics speak of asking, when are we concave up? And since the second derivative is always positive, we would say we're always concave up. That means we're always in a state of acceleration. Always accelerating. Therefore, never decelerating. Okay, let's jump to a cubic. Let's look at number 4. So our first derivative is our velocity. 3t squared minus 18t. If I factor out a 3t and set this equal to 0, I get t minus 6. I get t equals 0 or 6. Not interested to the left of 0. If I put, let's say, 1 in here, I get 3 minus 18 negative. If I put 10 in here, I get 300. Minus 180 positive. Let's take a look at the graph. Upside down parabola, but eventually wants to be a positive cubic. Oh, so my squirrel goes left, and then, which is represented by down, reducing position, and then my squirrel goes to the right. So therefore, squirrel changes directions at t equals 6, moves left from 0 to t equals 0 to 6, and moves right from 6 to infinity. And acceleration, the derivative of velocity, 6t minus 18. 6 times t minus 3 equals 0 when t equals 3. So acceleration is 0 here. Put in a number bigger than 3, like 5, and I get 30 minus 18 positive. Smaller, I get like 1, I get 6 minus 18 negative. So we would say that's cupping down, concave up. So when is acceleration 0? At 3. When are we in deceleration? We are decelerating from 0 to 3. We are accelerating from 3 to infinity. Well, there's not much to that. Make sure I didn't miss anything in my instructions on acceleration. The time t when acceleration is 0. Okay, it's sort of implied. T equals 3 is when acceleration equals 0. Okay, and let's do a quartic. Let's take a look at number 8. So here we've got velocity, first derivative, 4t cubed minus 45t squared. Let's think of the graph of that thing. Let's look at the graph of the original instead. We got an upside down cubic at the beginning, but eventually wants to go up in both directions. All right, so my squirrel ought to be going left to begin with, and then start going back to the right. So let's take a look. I can factor out a t squared. I get 4t minus 45 equals 0. T equals 0, that's a double 0, or t equals 45 on 4. Let's see, put in 1 and I get 4 minus 45 negative. Good, that's good. My squirrel's moving backwards. Put in something bigger. What we understand is we get bigger and bigger and bigger, this t cubed is going to take over and positive is going to win the fight versus negative. So our squirrel changes directions at t equals 45 fourths, seconds, minutes, whatever our unit is, and then we are moving left when the graph is decreasing, the position is decreasing from 0 to 45 fourths. Now I understand we're moving left all this time as we're going down, but we're only interested in 0 on, and we're moving right from 45 fourths forevermore. Acceleration based on time, 12t squared minus 90t. I'm going to factor out a 6t. I get 2t minus 15 equals 0. T is 0 and 15 halves. That is when the acceleration equals 0. If I put in a number like 1, I get positive 12 minus 90 negative. And take a look, because of this cubic, we are cupping down for a little bit. We are cupping down there. So this is negative. If I put in a big number, the squares are going to beat the non-squareds eventually. Positive. So we are cupping down here. And notice we have a change. It's probably cupping up after. It sure looks like it. Cupping down, and somewhere in here we've got an inflection point where we start cupping up. So we are in deceleration from 0 to 15 halves, and we are accelerating on the other side of that inflection point. 15 halves forever more. Once again, out of vision here a little bit. You can go back through that. Apologize if that was a little bit quick. A tight schedule. I wanted to get that out to you as soon as we could. Obviously, any help that I can give you, I would love to do.